All right, hello everybody. Welcome back to another episode. So today I want to model some actual hats, right? So far we've just been doing settings for doing holes for mounting like COTS hats you buy from like a supplier. So now I want to look at actually like doing like a custom 3D printed modeling version. And so that's going to need some code. I have from I basically have a library for like drawing sketch lines between like a point and like a circle. So like doing like tangent connections. So we'll be taking advantage of that. I guess one update from yesterday, I updated the API on my lookup table generation stuff. So it's actually a lot similar to like the actual direct code now with the similar keys. Although like default uses a number, so it's like an index into the array as opposed to like the actual name, just because it's a little easier that way. And I wrote like a little utility function to make, just to generate like some lookup payloads for me. But like the result output is the same, so hopefully it's a little more usable now. Although I don't think I need to do anything more for this project with it. But yeah, so if you're looking at the code, the code should be the same. Anyway, but yeah, so let's get into it. So the first thing I want to do is I want to add an enum for whether we're doing like a COTS mounting bearing hole or a standard one. So we'll say, what's a good name? Supplier, maybe? Or maybe like source or something is more appropriate. So we'll say COTS, and then we'll say like custom. Right, so custom will be like a 3D printed version, and then COTS will be like one you bought. So, like COTS being commercial off the shelf. Is that right? COTS, okay, all caps. Perfect. And we'll say source. Part source. Yeah, we'll do source, I guess. It's a little generic, but I mean, this is, I don't know, I think it's reasonable. Okay, so then I'm going to do an enum parameter. We're going to name it source. Definition of source is source, right? So again, using like the naming convention, right? This is capital case, and then this is camel case, so like bearing edge, and then usually, and then this will be sentence case. It's just kind of like the Onshape standard. One thing that kind of annoys me sometimes is I see people doing like capital case in their parameter names or things, or just like, I don't know. I think it's helpful to like follow the standard. It makes it a little more consistent. But if you don't want to, that's not a big deal either. But it makes me happy. Okay, so source, we'll do a UI hint. So we'll do remember previous value, of course. And here I'm using, like, this is equivalent to, like this. This is just a shorthand. I know all the names of the hints, so it's not really a problem for me. But obviously, if you're just, you're starting out, it's helpful to have the autocomplete. And then the other one we need is horizontal enum, of course. Yeah, so horizontal enum, the two major enum predicates, basically all your enums are usually going to be remember previous value, but the two options are either horizontal enum or display short. So we're using display short before to get the label. Otherwise, horizontal enum just gives you, this style across the top as opposed to like a drop down. So we like that. Yeah, so then, let's see here. So then we have to kind of do some editing, right? So all of this will be the same regardless of selection type. but then we will have different settings down here, I'm pretty sure. So we'll still have hole diameter, and I guess we'll still have fit too, technically. Will we still have fit? I think so. Let me think here. So if it's COTS, yeah, so you're not gonna select a bearing hat like this. So this is definition.source dot COTS, right? So this will be only COTS. But I do want the user to select this hole size regardless. So I guess I'm gonna have to make one for just the hole fit, right? And fortunately we can do that. I'll just copy paste this, print. Yeah. Tables. This will be my fit node, right? And then we won't export it. Right, so then I'm just gonna, so instead of making like a dedicated feature, I'm just gonna hijack this one because I'm lazy. But bearing hat tables, right? We need that feature. Right? So I'm just printing it out. I'm just hijacking this feature to do that real quick. And I did not code it correctly. Right, you are a number. Okay. Anything else? Nope, perfect. Okay, so here's our tables. Right. So all I did, right, was I just printed out basically the subnode. So like this subtree here, I made its own lookup table, right? So I'm just gonna copy paste those. Nice, right? So you can see it's just that last node flattened. So we're just printing that out into its own table now, and then we're gonna use that here, right? Fit, and this will be our whole fit table. There's a lookup table path, right? Cool. And technically, actually, now that I think about it, I think they don't actually even have to be the same lookup table. So I think what we can actually do is always show this, right? And then we just remove the fit node from here and here. Right, so this is a little sneaky. But basically what I'm doing is I'm splitting these into two separate tables, right? So let's print those again. Because basically the idea, right, so we just paste those, not two consts, please. Okay, right, so if we do it like this now, right, we commit that. Yeah, so you still have your close and your free, right? But when you switch to custom, it's the same, right? So like, it looks to the user like that's one integrated table, but it's actually two stacked on top of each other. But you know, Onshape doesn't like create a distinction between them, so it looks the same, which is helpful. Because this way, like, we don't have to do logic depending on what source has been selected to determine what option to use. So then we can just do this, update our code, hold fit table, definition dot hole fit, right, get our hole diameters the same. And technically we don't even need, these can just be the values then directly. And these could also be the values directly, but yeah, Yeah, okay, and I'll update my utility function. So we just don't need the key anymore, and we just need the value. And I think I made a literal for this as well. Okay. Oh, I did not. Need to export this. Go back. Okay, cool. Inch payload, yeah, and then we just need, we don't need the key anymore. Because we only have one value in this table now, right, we can just, I guess I'll update this documentation. So basically, instead of this, now we're doing this, right? So it's just 2 inch and then, the value of that width as well. And so if we print this out again, oop, really? I need this overload. And realistically, this should probably be a string, but we'll just do it like that. That works. Next is string. Weird. Okay. Not actually sure what that's about. Weird. Is this how I have it coded? Okay, this is turning into me just editing this. Maybe this is supposed to be next. Define, I guess. Well, I guess we'll just leave it like that. So we'll do this. Next is next. Okay, this is definitely a little hacky and probably not the most logical, so I probably will clean this up at some point later. But for now, just because I am recording, we'll keep moving. Okay, so there's our code. So that worked now, it looks like. Yeah, so if we paste this now, right, so instead of having like this, building this map at the end, right, instead now we're just getting the direct values, right? So we're going directly to that. And I'm realizing I don't even want the quotes here. So I did that wrong. And I'll just fix it real quick because it's easier. And then, to actually fix it, I would just get rid of that because this converts it to a string. That's right. So I don't need the quotes. Okay. Ta-da. So that's that. So now then, right, I don't need that call anymore. And then, so here there's our bearing hat. So this is just going to be const width, right? And then our hole diameter. Look table. And this will be our hole fit table, right? And this will be our definition dot hole fit, right? And then we'll divide by 2, right? Oh, I guess we need hole diameter. Okay. And actually, maybe instead I'll just do hole diameter divided by 2. It's a little easier. Okay, cool. And then we just update this hole diameter. Okay, that's the same. Oh, no, we don't have the dot axis now because this just returns the hole diameter now immediately. Because there's no map to dereference as the final value. Okay, cool. So this still works. So we're happy about that, right? And it still works regardless of whether you have COTS or custom selected. So when you have COTS, you just don't have the born width now. Cool. Okay, so that's good. So now then, what I want, or what I was thinking for selection, right, is I think there should be the option to select basically what points you want. You could also do like width and like shenanigans like that. But I think I'd rather be a little more custom. Although now that I do think about it, it probably would be helpful to be able to do a standard design versus like a truly custom one. But I guess I'll just start with the custom options, and then I can actually, that's a good point. Let's start with that, I guess. Yeah, I guess I could just have a model hat version inside the COTS component, but I don't know. I want to distinguish between just cutting the holes versus like actually doing a 3D printed one. I don't know. Let's just model the hat, I guess, for now, based off of if source is true or not. Okay, so hat modeling. So yeah, this is going to be, well, let's see. I also don't have that much time today. How do I want to do this? Okay, so I think I do want this. I think I do want a query. So we'll do points. Right, and I'll limit it to 3 points, I think is reasonable. And then this will be, it'll be the same as the sketch filter. So it'll be entity type dot vertex and then sketch object dot yes, and then modify only dot yes, or body type dot make connector. Okay, and maybe then, so I guess what I'll do, right, is I'll say, okay. And let's see, actually, I'm curious now. So these are, okay, so there's end plates and center plates. So maybe I'll do center. We'll just do standard for now, but eventually I could see like center end if I do want to support end plates, but one thing at a time. All right, so yeah, and I don't need this import technically. Because that just prints the table, and then once the table's in the source code, I don't actually need the import anymore. Okay, so custom hat type, standard custom, okay. And then, yeah, so then we're gonna use that. And I'm gonna do it down here, I guess. I could also, I was thinking of doing it at the top as well, but I don't know, we'll see how I like it. So hat type is custom hat type. And then we'll do UI hint, remember previous value. And I won't do display short because I think it should be self-explanatory, but we'll see, I guess. So then we'll do if definition.hat type equals custom hat type dot standard, right? Then we will show the hat. Okay, so that complicates this actually a little bit. So we need to do, right, so you're not allowed to duplicate parameters. And it is helpful to reuse parameters where possible, because that way if the user has something set and then they change the options at the top, it carries over, right? So what I'm gonna do is move this down here, right? Because we need to have this feature first. So I'm gonna change this to custom. Right, so we'll always have that. And then this will appear if it's source, or if source equals source.custom and definition.hat type dot standard. Yeah. And this will be custom. Right, so the logic is a little obnoxious, right? Definitely not my favorite thing to do in the world. Okay, then we don't need that. Right, and this is where like having the auto format can be helpful because it can help identify where, you know, you're missing, like if you have a missing parenthesis or something. But yeah, so basically what's happening, right, so if it's custom, we need to show the hat type first, right, and then if the hat type is custom, we show whole locations, right, otherwise we show the bearing hat feature or lookup table if you are having cots, because you need to select that, otherwise if we are custom and the hat type is standard, as well as the other option. So it's just kind of how you have to formulate it, I think, to avoid like reusing, because you can't like have the same parameter twice. It's just one of the unique limitations of Onshape predicates. But that results in a UI like this, right? So you can see when you choose custom, you get the custom type. And if you choose custom instead of standard, so with standard, it's just like the same as COTS, right? So when you switch back and forth, it's the same because it's the same table underneath the hood. But then you also have this option of changing to custom and selecting your specific hole locations. And then the whole location selection is, you know, the same as, you know, the Onshape like hole feature, right? And so maybe this will be sketch points to mount to or something like that. Adopting that standard of saying like, you know, the type of selection you can make and then like what it's for. Yeah, sketch points to mount to, sketch points to place holes. Same thing. Okay, cool. Yeah, so that's that. Now this is quite wordy, but, well, yeah, we're just gonna have to, okay. So we're happy with that. Okay, so now we start looking at some of the logic, right? So I think we've written enough stuff here now that it starts making sense to start factoring some of this stuff out. But I guess before we do that, I guess we'll keep cracking on. Okay. So we'll have the user select everything there. That's fine. And then if definition dot source equals source dot custom, right? Definition dot what do we call that? Hat type. Custom hat type dot custom, right? Then we need to verify that they've selected a query. So these are, we'll call them mount locations. Place mounting holes. locations, right? And then this will be something like that probably makes sense, right? And I guess I'll move this into its own little logic here. So I'll nest these, because otherwise the logic should be mostly the same for this, but it's not guaranteed. Okay, hum-to-dum. So we have that. So that will verify now if we have, if the user needs to select mounting locations or not. And then here's the rest of the circle plane. Okay, so I definitely need a function here, at least one, because this is otherwise getting a little messy. The other fun thing I'm realizing is if they are not selecting, if they are making a custom hat, then let's see here. So if the user is making a custom hat, they don't actually, it doesn't make sense to have them select like angle references and all of that, because they're just going to choose where they want the mounting holes, and then that's going to be that. So it removes like all of this stuff basically, except for like flip primary axis technically. Like, yeah, because you don't need any like angle reference or anything like that, because there is no like angle or things. You're just like selecting your locations, which is a pretty big change actually. So that means that this needs to come up top. But I'm annoyed because like I could do it up here. Well, okay, all right, it's just gonna, yeah. Okay, let's try this, I guess. So I'll steal this. And then we'll do this. Not hat type. And this UI does have to come up top because you can't use UI after it's declared, or it has to be used before it's declared. So if I want to like do conditional visibility off of this, it has to be above anything I'm doing visibility of. So if I want to hide these, this has to go above it, basically. If I want to hide these based off of the value of this. And now I'm wondering if it's even worth it or not. I could also do this. Name custom hat. Standard hat. Design, and we'll leave it as source for now. Maybe I'll rename it using Control F later. Maybe that's a little bit better actually. Let's see how that looks. Okay, I did not like that. I guess I did botch this. Control F that. I just want to see what my enum looks like. Standard hat, custom hat. I like that. I think that's reasonable. Yeah, so this is a standard hat. This is a custom hat. Okay, and that simplifies the UI a fair amount. So I'll roll with that, because then I avoid a lot of nested conditions and things. So then we'll do this. So if definition dot and I'll change this to not equal custom hat. Actually, it's probably easier to do this and then have this be the else block. Right, and then this will come up here. And we'll slash that out. And then I'll drop this onto its own lines so it's a little easier to read. Oops, okay. Okay, and then this will happen when definition.source does not equal source dot custom hat. Yeah, yep. Okay, cool. So, yeah, so when you get cots, you get like this. Otherwise, you end up with this, right? You can select your sketch points to mount, right? So if I want to do a hat like that, you can do that. And then there's that as well. Well, that's all the way down there. Well, these are selections technically. They are technically part of the hat design as well. So I could see it going either place. I don't know how I feel. Bearing hat. Maybe this isn't the best description. I don't know though, I could call it like mounting holes. Or I could just put this down there. I think I will do that. Because it's more of the hat than anything else. And then we'll keep this condition. Yeah, we'll just clean up the selection dialog. And then I could just get rid of selection entirely. Yeah, it's also kind of goofy this is still down here. I could get rid of flip primary axis entirely. But again, because the hairstick should be good enough that I don't need it technically. But I do like having it for posterity or something. Yeah, because the problem is this first in row makes it look kind of goofy. But like conditionally having it based on whether you have secondary axis dropping down, like I'd have to copy the parameter basically and then alternate which one is showing, which is very cringe considering the parameter doesn't need to exist at all. Let's try this, I guess, and see how it looks. That ends up there. I could do this. This is an option. So we just don't have that option at all for the custom hat. That's so weird though. Yeah, this is also too long. This might just have to be like... Let's see, what does external thread do? Cylinder edges, yeah. Maybe just that. Deviate from the standard a little bit so it's a little more concise. Okay. Is this really how we're doing it? I could keep the rotate secondary. The problem is it just doesn't make sense when you're selecting, because there's nothing to actually rotate. Other than like the bearing hole, but like that's so, you know, arbitrary, it just doesn't matter. Same thing with like angle reference, it just doesn't, you know, there's no meaning there. I'm realizing I do need the bore option, even when you're doing a custom hat, which is sad. Because the one limitation of lookup tables is you can't do custom size, or you can't do any conditional visibility off of them, right? So it all has to be done based off of like higher level enums. So if I wanted bore here, I'd probably have to make my own custom bore. I'm also realizing I do need bore in the table when you're actually modeling the hat, because you need the bore size to know how big to make the hole, or what style to use. So we're gonna do that. And I really want this to be a size. Okay, so I'll make an enum bore size. I could actually use the values, right? The problem is I do want to check explicitly what bore size I have because it's like hard coded. I don't have like generic code for it. And so this is a little more explicit, basically. Okay, so we'll add that there, and that adds that. Okay, so yeah, and then I do need my map back again. Okay, we're flailing around a little bit. So this will be a map, this will be width. This is really more width payload now. We'll just do that. Okay, and this still, yeah, it's still okay as a string. Okay. Cool, so that's like that. If we are going to do bore size without the width, because this depends on it. So I would need this, I need this node as well, basically. So this is just the bore node. Okay, and I'll just dereference it. It's not worth fighting having the whole diameter versus not. And width node. Okay. Uncomment that. Print the tables again. We'll copy paste them in. But while I'm doing that, yeah, okay, I'll just do that real quick, I guess. Okay. Yeah, so definitely spending a bit of time here just messing around with the UI. Probably more time than I should be. But I don't know. It's a nasty habit of mine, I suppose. I did not do a good job of specifying that. So, oopsies. Oh yeah, I forgot that the enum would just be the string literal, so it would drop the, yeah, needed more quotes probably. Okay, so here I need the bore table. Okay. And if I really wanted to nerd out, I would use editing logic to synchronize these two when you change between them. When you change between like custom and, you change your hats. But I definitely don't care enough to do that. So we're not going to, thankfully. Okay, and this will be custom hats. So we do, simplify the references a little bit by combining those into one, which is nice. Okay, and then I need to get this is the same. Okay, cool. Alright, const standard. Yep, so you still get your bore size, right? You still do your fastener fit, which is good. Yeah, you can do your free and whatnot. Okay, cool, we're happy with that. Yeah. Okay. So then, yeah, so this is your basic circle plane. And then we only need this stuff, all these transforms and whatnot, if it's not, a custom hat. So we'll do that. What is this? This is just UI stuff. This can probably just move up, I think. Yeah, although I guess it does make sense for this to come after this. Okay, so we'll keep it like this for now. Okay, and then here's this transform, and here's the angle manipulator. Okay, do we ever come to a decision on custom hat? I guess we'll just get rid of it all. Or maybe, all right, you know what I'll probably do? I'll probably always keep the flip primary and secondary axis just because, like, old time's sake. But it just won't really do much for the non-custom hat case. So it's a little goofy, but I think it's easier just to keep it consistent and not worry about it so much. Yeah. Yeah, I could also just have the secondary button, but I like this. I like the visual consistency of having them both. I do think that's helpful. So yeah, so we'll always apply this guy here. This code here will always run, and then we won't apply the angle if it's not a custom hat. And we do have to keep the order because we do have to apply the transforms in the correct order. That's important. So yeah. Alright, does this need to be here? It matters for the manipulator, so it has to go somewhere. So yeah. Okay, and here I'll use a with if var with Okay. So variables have to be declared before they're used, and then they're trapped in the scope they declare them in, right? So if you just did this, right, then you don't have access to width out here, right, because it dies at the end of the scope. So what we have to do is we have to declare the variable up here, right, and then we're naming it constant because we're going to set it. So here then, and then this will be const table equals and this will actually be down here, and this will be up here. So here then width will just be get lookup table, bore table, bore, and this will be dot bore. Otherwise we'll get our table, and then our width will be table.width, and our whole diameter will always be the same. Yeah, and then we'll also do var bore. Right, and then width won't be set for custom hat, which is fine. Although definitely a little goofy. Yeah, so this is where like functions would probably help clarify some of this stuff, because there are a couple things going on here in terms of getting variables and whatnot. It's definitely a little confusing, but that's okay. I'll keep writing, and then at the end I do want to go back and add some functions and things. But I do think it's easier just to write it all right now, and then because then like once I have my variables figured out, I can go back and do that behavior. Yeah, so we'll do that. Okay, so then here, right, that's all good. And then here, right, so here we have a decision, so it matters exactly what's happening. Source equals source dot, yeah, so this always happens because these are the mounting holes. The mounting holes can be different depending on if we're custom or not. So this is the else branch of that. Right, and then we're going to need to sketch the body itself separately when we actually go to model that, which I'll probably do after the end of this stuff here. Because I think it makes sense to model the, or cut the mounting holes first. Does it? I guess the hat itself is more guaranteed. Okay, I'll probably do the hat first, but that's fine. So here, right, I'm going to need to loop over, okay. So I need a variable of mounting locations. And here we'll do const locations equals that. And then I'm going to, I want to set up planes basically. So I basically need to map this array. So I'm going to do that in line like this. I could also use a for loop. So this is going to be location is query, right? So I'm taking advantage of the fact that verifying on empty query returns the array of individual queries, right? So the result of evaluating the queries, using this, right? It's equivalent to this code here under the hood. And all this does is it takes a query, because a query is just a set of instructions for some geometry in the Part Studio, so it's not meaningful in and of itself. But evaluate query will run it against your Part Studio and figure out what it maps to. And then it will return an array for each individual mapping. So in this case, each location will be a specific point the user has selected, which is handy. And then map array just iterates over an array and calls a function each one, and then whatever that function returns is what the new array becomes. So here I'll use my evaluate vertex point coordinate system again. We'll pass the location, right? And then I will convert this into a plane. And actually, no, I don't need the point because I just need the location of the point. I don't actually need the specific like plane or orientation. And actually, technically, that means this doesn't even need the sketch filter because we're getting it from the bearing hat itself, right? We can just project all the points. That already gives us our direction. So we can open this up a little bit, make it easier for the users. So we don't need this sketch object requirement. Also require modifiable entity though, just because posterity, I think. But yeah, so const point equals evaluate. So if we just need the point, then we can just use this. Evaluate vertex point, right? Although this won't work for, oh, it will work for make connectors as well, so that's good. Cool, and then we'll project this onto our circle plane, right? And our circle plane might get a little rotated. Okay, so to avoid, we want to project onto the final circle plane, right? So we're going to move this logic down here. Yeah, okay. Cool. I guess I'll just keep this in line here. No, we'll do it like that, I guess. Okay. Yeah, so if I return this point here then, right, then I'll have an array of points. And actually there's one more thing I want to do. I actually want, instead of projecting it, I'm going to make it a 2D point. Is that right? Yes. Yeah, so I'm going to use world to plane to actually transform it onto the plane directly. Right, so instead of being a 3D point in space, it'll be a 2D point. And this also, I believe, implicitly projects it as well. So that way we just have that. And then here, right, we can just add our vectors directly, right? So this will be negative width divided by 2, 0 times meter, right? And then vector width divided by 2, 0 times meter, right, is the location of these points. So that way we get our mounting locations. Right, and this is the exact same as down here. These should be meter technically, just for, it's a little more efficient math-wise. Because like meter is like the default, or is like what the unit will actually be under the hood. So yeah, so this is just the exact same logic as that, right? With, and I guess we'll use, yeah, negative width, but yeah, it's just the two locations, right? For the standard hat design. Okay, cool. Yeah, and then we'll go ahead and make the hat itself. So for that, or well, I guess we're not quite there yet. So then here, right, I'm just going to loop over our mounting locations. And actually, this can just be like this. Right, and then here we can instead do right, and then we can just sk circle location, right, the whole diameter is always going to be whole diameter by 2, and then this needs to be some index, right? So we'll do our I. So this will be like mounting hole 0, mounting hole 1, mounting hole 2. So that way they all have a unique identity, right? And this way, right, and this will always happen, right? So by doing this, right, we've genericized the logic for all three, which is kind of neat, right? Because if we always populate our mounting locations array, right, then it doesn't matter if we have, one or more mounting locations or how many we have, we'll still get the same result. So this hasn't actually affected our logic for like the COTS case at all. You can see that it still works because we're still iterating over those same locations. And then same thing for the standard hat because we have the same logic there. And then the custom hat, you just have to select your locations, right? And that is hooked up, so you can see that does work as well. So yay generics, we're happy with that. So now we're going to go ahead and try to model our actual hole, right? Or model our bearing. So yeah. So for that, we're going to use my old... okay, so let's see here. So this is my robot boundary. Or let's see here. Oh, I do have an STD hole. Oh, that's cool. Let me use that, actually. I forgot I have a standard... does it need to be exported? No, it doesn't. Okay. Yeah, I forgot to keep a export of some standard like whole library things and stuff because I use, I've wrapped around the whole feature in the past, and extrude, of course. I have a couple features actually that are like one-to-one wrappers around STD extrude, or around the Onshape hole feature, or around the Onshape extrude feature. So I keep some utilities for that. So for example, I have this hole diameter bounds. I already have it saved. So that just lets me use that instead, which is nice. And actually, maybe I even have a predicate for this, if I remember. Hole diameter. Yeah, I do. Okay, ta-da. Right. And a predicate is just export. So you can see this is literally just that function wrapped in a predicate. So I can call that instead of typing it out by hand again. So just a little bit of reusability for my own personal library, right? Of course, you could also just copy paste it like I had before, and that works too. Okay. Yeah, so here's boundary. So this is my boundary library. So this is basically like for drawing like tangent lines and things between whatnot in like using 2D sketches, right? So the basics, yeah, it has an identity, a location. Is this 2D or 3D? I don't remember. It's a little embarrassing. If I had to guess, yeah, it's 2D locations. I'm gonna update that. Is 2D point value dot location. Okay. Yeah. Oh, maybe that is 2D point didn't exist back then. I'm not actually sure. Hard to say. Okay, yeah, so there's a bunch of utilities in here for connecting at boundaries, basically. So I think the idea is you have your plane, and then you have some utilities. Yeah, there's some sketch connection. So this is just like really low-level geometry utilities. But the key is you just like make a couple of these generic guys, and then it kind of works. So that's cool. I'm gonna need to populate that actually. So which we can do. That's not too bad. Radius, yeah, and then flipped. Okay. Right. So the other piece of UI we're gonna need is we're probably gonna want the my wall diameter stuff, which I also have code for. A lot of this is just composing some of my existing code together, which is fun. Yeah, so I have wall type, and this needs to be exported. All right, still don't need this, technically. Move that up. Okay, so for wall type, comment that out, or just delete that for now. Okay, so wall type predicate. Yeah, so this is a predicate. And basically what that is, right, is it's this, right? So it allows me to select a wall thickness or outer diameter. So this is for specifying like how much room you have around your holes, basically, right? So it's a pretty common piece of code. And I believe there's also a editing logic as well associated with that. Yeah, wall edit logic, wall definition, new definition. It does want specified parameters, so I'll add that. I believe it just sets the outer diameter based on your hole diameter. So that way, if you have it set to outer diameter, and you change this to, you know, like 0.5 or 0.5, nope, it doesn't. What does this do? Embarrassing. Yeah, so it's supposed to update. Oh, I guess it changes when outer diameter changes. So basically what happens is when you change from wall thickness to outer diameter to avoid crashing the feature immediately, if your outer diameter is less than your hole diameter, it just sets it to twice that. So that way, you know, it applies logically. And actually, now that I think about it, I guess twice that's about reasonable, probably. Maybe not. Maybe that's a little thick. Yeah. Okay, I guess I'll just say it. So I'll have it apply whatever wall thickness you had set instead. I think is reasonable when you're changing. And yeah. Okay. Cool. So just a little bit of usability there, in a standard function. Okay, and it is getting somewhat late, but so I probably should go to bed if we're being completely honest, but at the same time, I don't really want to. So yeah, these should technically be like this. I'll just fix it real quick, I guess. So I don't have the enum twice in here, because it's kind of goofy otherwise. That was named bore size. All right. Yeah, I'm definitely going to have to go through and clean up this code, because it's definitely getting a bit unruly. But we'll keep cracking on. All right, so modeling. So I need my boundary code here. Okay. All right, let me just duplicate that. Hopefully I'll remember to switch back and forth. Okay, so if I'm understanding this correctly, let me see here. May or may not be flipped. Yeah. And I guess because I'm doing this, I really don't have to do anything too fancy, because there shouldn't be anything crazy going on in terms of like giant arcs or whatever. Or I don't have to worry about like a lot of this code is for drawing in like the arc specifically on a boundary. as opposed to like just like naively drawing the circles and like connecting them with tangent lines. Because, you know, there are edge cases where if you're doing like a concave plate or something, where if you just draw a circle instead of an arc, like the actual arc you're supposed to have, then, you know, you get a much bigger plate than you want, which is sad. But I don't actually need that here because, you know, if you think about like a little standard plate like this, there's not really any situations where this circle is problematic, unless this is like really big and like here and like eating through that way. And like, you know, that's obviously an edge case I'm not really worried about. So that should clean up a lot of this code actually. So if that's the case, then we're probably just going to need our circle to circle function. And that connects two circles, and then you can say whether or not it's counterclockwise. And then, yeah, so I'll start just with a basic case where I connect all of your selections, all of your mounting points to the center. And I do want to think about a case where you like connect them together, but one thing at a time, especially if I'm going to allow 3 selections, because that could get awkward. Yeah, so boundary circle is just a 2D point, and then you have a radius as well on there. And this is just a standard map. And then you can also flip it if you're, that's more for arcs, I think, if you're doing things like that. But yeah, so for this, we can probably just hard code it more or less, right? So let's do that. So okay. So our circles will be let's see here. So we'll be using circle to circle for our sketching. Okay, and this takes, what did I call them? Boundary circles? Okay, so again, I'm going to map array. As vector is the most generic type. Okay, so yeah, so basically this is just going to be as boundary circles, right? So a boundary circle, right, consists of, I guess I can go back and forth. So I have an identity that's optional, and then a location, radius, and whether it's flipped or not. Yeah. So radius is always going to be okay, wall diameter, definition, and then we'll have our hole diameter. Right, so this is from my library, of course, and then divide by 2 for radius. Flipped will be false, I think, just always. And then identity, right? So if we are what did I call it? Source. Source.custom, right? Then we can use locations I. Oh, I guess this doesn't have an array. Okay, fine. I'll actually do it. Okay, so I was trying to use map array, but I do want to have the index. So instead what I'm going to do is I'm going to do an actual loop. So that way I can get the index like this. And then for I location in mounting locations. Right, so this is a little more verbose, but that's okay. So then we'll have to do So I'll grab the locations here like this because it's helpful to have because I need the query here. Because basically what this is doing is this hooks up the identity for the circle. So this will actually track it through. And that's for some robustness stuff. So basically it ties whatever selection you've made to like the sketch point you've selected. So it's not like completely arbitrary, which is helpful. Okay, and then we do need to, when we're detecting these, we do need to determine whether or not we're actually centered. So we'll do that by getting the center, which there should be functions for. Aha, okay, still got it. And so this will be append mounting locations, and then I do also have the, oh, centroid's ordered? I think it is ordered. That's weird. What is the order? Technically it keeps coming back to the center if we're doing this properly. So like the center should be in here multiple times. And because of the way we've defined our sketch, right, our origin is just the 0 vector. And I guess if that's the case, then I guess our centroid can just be the 0 vector, really, because that is just the center of the plate always. Or like that should always be the center. If that's ever not the center, then something's clearly wrong. So I don't even need to do that. And like all compute centroid does, I think, is it adds them up, and it takes the center. This should really take the centroid as an argument, I guess. Are there use cases that are going to complain about that? No. I'll comment out these. These are just some tests I wrote a long time ago to verify some of the logic, because I was playing around with angles and stuff and it was getting kind of complicated, and I wanted to make sure I was actually doing it correctly. Is vector. Okay. Cool. All right. So with that, we can come down here. Yeah. So our so const is clockwise equals is okay. Wait, is it? Generally counterclockwise. Oh. Okay, but these take, oh, they do take counterclockwise. Okay, cool. All right, I couldn't remember if I changed it to clockwise or not. It doesn't actually matter. You know, it's just a negative sign, but, you know. Okay, so this is going to be the 0 vector times meter, right? So that's just, you know, the 2D 0 vector. And then we have our locations, right? Or mounting locations specifically. Locations is the array of queries from verify non-empty query, right? So we don't want to use that. And then we need location here, right? And this is going to be our location there. I guess we'll disambiguate by saying mounting location. So we'll make it explicit. Oh, location. Okay, cool. So there's our boundary circles. So theoretically now then, we can, let's see here. So if we look at my code again, we will go back to boundary. Okay, so there's various functions for connecting stuff up and measuring and whatnot, but I think we should be able to just use this. It takes identities? Oh, is this not required anymore? Let's see, none of those need it, clearly. Add arc. This one won't. Oh, okay. So this doesn't actually even need... Identities is separate. I guess I factored it out at some point. I just didn't update this documentation. So we don't actually need the identity, which is helpful. Let's just check again. Identity, yeah. Yeah, there's not actually any code for here. It's just in here for the connecting lines. Okay, so that's cool. That's helpful. Yeah, and that checks. Okay, that's cool. Okay. Yeah, it's been a while since I used that module. Okay, so we don't need this here. And that means we can use map array then. So I guess we will. Locations, function, location is vector. Right. And so we can once again go back to this, right? So it's just, you know, very similar syntax, it's just a little more concise that way, which is nice. And actually, let me see. I thought it might have been, that's notices. Yeah, I am for pulleys. Interesting. This is just a separate feature script, so this is just me checking my code. Because I didn't realize identity wasn't actually being used like that. Although I think I was using it quite a bit. Okay, here I do my own identity stuff. Okay, maybe I will... Okay, let's back up the bus here. Okay, I'm flip-flopping all over the place again, which is awkward. Okay, so I'm gonna back this up. Boop, 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 boop. Okay, so I am going to keep identity in here. And I am going to keep identity in here as well. Okay, so we're going to do that. Because I do think it's helpful to have, even if the API doesn't necessarily take it directly. So we'll do that. Okay, now that we have that, we can get our connecting points. So for var I circle in mounting circles. Okay, so this part I can use circle to circle. And so here I need to use the previous, I'm pretty sure. And so fortunately I have a function for that. So this will take circle and I. Oh wait, this takes the array. Okay, and we'll call this cur for current. So cur and then counterclockwise. Actually, now I think about it, it's a little more complicated than this. So, yeah, so the center location, okay, maybe I will actually hook this up properly. So our center location looks like this, right? So the identity is definition.bearing edge, right? Our location is going to be the 0 vector 2 times meter, right? Our radius is going to be based off of our bore size. So bore equals bore size dot. So this will be probably 1.25 times inch. Otherwise, it'll be 1 times inch for the 0.875 inch bore, right? And then it won't be flipped. Right. And so basically, right, if we think about this as a boundary and the start is connected to the end, the center circle should actually be in mounting circles quite a bit. So I think it's just like this, right? So if we think about this logically, this is like saying you start at center circle, you go to the first circle, and then when you iterate again, it'll be back to the center circle, right? And then you'll go to the next one, and then the center circle, and then the center circle, and back. So this will go out and back to all of them. And then we can still use this 0 vector as the centroid, but we could actually compute it that way if we wanted to be like super accurate. But that's fine. And then, yeah, so then when we iterate over mounting circles, right, this will give us all those connections, which is good. Okay, cool. And so now we can go ahead and iterate over and do our sketch, right, and do all of our sketching. So we'll iterate again. I think this is where you sketch. Let's sketch arc, sketch connecting lines. Right. Extract from array of maps. So this just iterates over okay. So what this function does, yeah, this is one of my custom functions that I use all the time. Basically, if you have an array of maps, right? So like this, mounting circles is an array of maps because every element is a boundary circle, which is a map, right? And so all it does is it iterates over the array and it collects a given key, right? So this is going to iterate over our mounting circles and grab all the identities and then put that into a single array, which is what that wants. Our plate plane would be our circle plane, right? And then I believe this should be ID plus like lines, and then our connecting points will be our connecting points, right? So that will sketch all the connecting ones, and then we can sketch the arcs as well. Is this a real function? This might not be a real function. Let's see where that's from. Yeah, I wrote that in there. That's for something else. Should it be? Maybe this should probably be in the other module. Well, okay. Oh, because identities is separate there? Okay, sure. That's strange. Why did I do that like that? Circles? Oh, I see. Okay, sure. Identities is array. Did I cut it? Oh, I did. Okay. Identities. This should just be plain as plain. Okay, connecting points is array, and then we do need to know if it's counterclockwise or not. Okay, so var I in identities, right? Oh, this does need circles. That's awkward. Okay, back up the bus. Hum-de-dum-de-dum. Plain, plain. Okay. All right, this is plain. All right. And then this needs to be circles. Okay. Points I and next index. Yeah, there's a bunch of shenanigans in here, but it should all work basically. Okay, so I think that's right. So if you go back here now, sketch connecting arcs, right? Circles, belt plane. Okay, cool. And that should be from boundary then, assuming this library. Yeah, this is a different feature. I'm getting very sidetracked right now, but I forgot to export it, that's why. Okay, cool. So theoretically, hopefully I didn't break my pulley feature. Let me just, or my belt feature, let's just verify that, I guess. That looks good. Once it loads. Okay, cool. So that looks very promising, so we're happy with that. Okay, that's my separate belt feature. It doesn't really matter right now, but yeah. Okay, and then we'll have our mounting circles here, right? Our circle plane, connecting points, and whether it's counterclockwise. Okay, so this should, in theory, sketch out the bearing hat for us. Although, if I had to guess, probably not, because I assume I did something wrong, or well, I see it's complaining. So let's take a look at that. Okay, map. Oh, oopsies, forgot to cast this to a boundary circle. Right. And I guess this is, okay, ta-da. Yeah, so, yeah, I don't know, what can I say? It works. That's pretty neat. And so you will notice it is making one sketch for everything in here, right? And you might say, wow, that's a lot of sketches. That's really unnecessary. Why are you doing it like that? And you'd be right. But basically the idea is we really want robustness, right? So in particular, because the user is selecting in arbitrary order, right? It's important to us that we are, how do I put this? So basically the way this works is every sketch entity is tied to the specific location or locations it's involved with. So all of these lines are tied to the two entities it's attached to, right? And then the arcs are attached to the entity it arcs around, right? And the reason we're doing that, right, is because basically that way, if you like were to reshuffle, like shuffle the order of your selections or like delete one, right? If you had something mated to like this edge or like mated, you know, along here, for example, it wouldn't, you know, jump to like over here or, you know, jump from like here to here, because that would be kind of bad and annoying and not great to use at all. And so that's why there's a bunch of code. And so like, and so the reason why we do sketches is because we can tie the creation of the sketch itself to, you know, these specific entities. So if either one of these entities is missing, then we know to not create, you know, like this specific edge, and instead do it some other way. I guess the other thing I'll talk about, I was, you know, kind of going through. So this is a custom type that I defined, right? And then I use throughout here. And so basically this just allows me to document, you know, my own custom map in this case. So, you know, and then I can get like some type checks and things with that. So all you have to do to declare your own custom type is you just, you can just type, and then you're asked to give it a name. So in my case, this is a boundary circle, right? And then here you have your predicate, and you can define whatever you want. So usually you'll say whether, so most custom types will either be either a map or an array. By far and away, the most common is a map. You know, so just a mapping of key value pairs. And then you just specify what exactly the keys and values are. And so this isn't really like a hard requirement or anything. It's more of just documentation. Although you can, generally like Onshape won't enforce these strictly. Although if you like monitor a part studio that's running your feature, Onshape will statically verify all of those things and make sure like all the type definitions and stuff are being met throughout, which can be helpful for, you know, testing and making sure everything is, you know, your expectations are matching your code and all of that. Yeah. So, yep. I kind of want to move this call into this function. I guess I'll do code cleanup later. So let's just focus on extruding this for now. And I have to remember how I actually do this. Because they're separate sketches, it's not as easy as just OP extruding them or whatever. Let's see here. Sketch edges. Yeah, I have to extract faces, I think. OP fit spline? Yeah, okay. What, plate common? Oh no. Are they really? I'm not using extract faces. Oh my god, I am. Wait, no, I'm not. Okay, good. Okay, I'm going to steal this function here, which does, and put it in boundary. Because it is a useful function. Bounding box length, what? Is that one of my core exports? Extrude through all, extract from map, clean up. Yeah, bounding box length. Okay. Yeah, so that is a core export, so I need to add that to boundary, which I can do. Toss that in there. Cool. All right. Ta-da. So there's that. So yeah, so the way this works, extract faces, constant plus faces, sketch entities. Edge and then circle plane. Const hat ID equals ID plus bearing hat. Right, so I'll just create a sub ID to use for all this sketching I do, so I can query it all at once like that. And then extract faces, sure. I'll have to do cleanup, of course, as well. Okay, ta-da. So if I'm remembering this correctly, basically what this does, oh wait, does this not even work how I want it to necessarily? Yeah, because this was designed to do a single plate. But in theory, I'm extruding face. Normal, I think negative, right? And this will be like 0.25 times inch or something. Oh, okay, look at that. Ta-da! That's neat. And if I remember how I do this, I have to go back and delete it myself manually, or I have to go back and extrude the holes manually afterwards, because that's not a part of this. Yeah, so basically shenanigans. So when you sketch all of the things individually, right, it's actually kind of hard to combine them back into a single, like, contiguous region. So what this function does is it actually it creates an arbitrary a surface of arbitrary size by making a fit spline that's the size of the bounding box, and then extruding that, right? So that creates a sheet that's very, kind of arbitrarily large, right? And then what we do is we actually split all of our, so we take all of our edges and we split that sheet with them, right? And then we simply remove the largest face, right? So if you think about like splitting, right, eventually that'll, leave you with basically you get like a bunch of subfaces, right? Like one or more subfaces, and then you have like the outer sheet, because that outer sheet is is arbitrarily large, it's kind of guaranteed the largest thing. So when you remove that, you're left with like all of the subfaces. So that's just how I did it. I don't actually know if there's a better way or not to do all of this. Obviously it's pretty hacky, and there's a lot of shenanigans going on to get it to work. I don't know. Yeah. Okay, so I'll add this to this, hat ID. Okay, and then okay, so I'm just going to do this, right? So this will be hat ID, entity type.body, and then I think we'll do a Q subtraction. Because it created a bunch of different types of things, like sketch objects and whatnot, I'll actually subtract off everything that's not a solid. So this is everything created by hat ID minus everything created by hat ID that's a solid, right? So if this is our part, then we do that. And actually, probably the better thing to do is bearing hat equals Q created by ID plus bearing hat extrude, right? So that'll just be our hat. So we'll just do this Q subtraction bearing hat, right? And you could even do then this then, right? Because the only thing we actually need to keep from this feature is the bearing hat itself. And I guess if we ever made like a MIDI connector, we would probably want to keep that too. But this is one way of doing it. Yeah, and cleanup here is just a thin wrapper I programmed around OP delete bodies. So it's just, very trivial wrapper. But I find the syntax is a little cleaner. So that's one of my standard features that I wrote. Yeah, so ta-da! So there is the outline of a bearing hat. So obviously I have to go back and still have some work to do. I have to cut the holes in it, and so I'll have to do the counter bore and the outer holes and do all of that stuff. But like this works with wall thickness and whatnot, and you can even do goofy stuff like that. And set your outer diameter, and so you can make your hat like that, which I think is pretty neat. And if we actually make this a little more realistic, right? So you can make little guys like this, and like big bore, and like free folds. And then if you're doing like a somewhat reasonable wall thickness, like 0.1, right? It kind of looks like a bearing hat, sort of. Well, if you use your imagination a little bit, maybe. Yeah. So that was a lot of connecting up my existing code. Yeah, and I'm also admittedly pretty tired today, so I probably didn't explain as much as I normally do. But hopefully that was insightful somewhat, or I don't know, good to put on in the background. Who knows? Next time, I'll be working on polishing up these remaining bits. I think there's probably some UI on figuring out how to specify whether you should like be able to connect these together, or how that works. Well, that might just be more of like a like FeatureScript workflow than like Bearing Hat specifically, I guess. Which is where a lot of this code originates. Is a long time ago I wrote a FeatureScript to like allow you to like select and like do like the tangent connections between entities. So yeah, I don't know, maybe I'll do a version where like it's hard with the pairs, I guess, without just doing like a full actual plate FeatureScript type of deal. Yeah, it's weird with the 3. I could limit this to 2 selections and just say like you gotta have 2, and then just have an option, if, like to connect them together. So if you want to do a triangle instead of like something like this, that might be more reasonable, honestly. Maybe I'll do that, honestly, because I think once you get to like 3, it gets a lot more complicated. You also like can encounter like concave corners and things that you might want to like put a fillet on, and so it becomes pretty unclear exactly what to do then. So yeah, and then you can also do standard hats, maybe. Oh, there's an error. Let's see what the error is. Let's troubleshoot that. Uh-oh. That's not fun. That's not fun at all. So that's okay. So there's some internal issue with the logic. Oh, that fixed it. Oh, do I need to not be having my width? I think that occurs when the circles are too close together, which I need to fix, to be honest, because that's not a good error to have. What's the distance here? I mean, that's 2 already. Wait, what? Oh, I did have to do that, huh? Oh yeah, because I'm not actually making the inner circle smaller depending on the bore size. Am I? No, I thought I am. 1 inch, 1.25, that should exist. That shouldn't be like a major issue. Oh boy. Circle to circle. It's complaining, that's for sure. Width divided by 2, width divided by 2. That's right. Okay. I'll shove this stuff in here. Equals cube nothing, so it doesn't kill my code. And then I'll do that. Okay. Should be able to set it to const. Yeah, that would do it. No, it wouldn't. I think our throw region error can be silent. Oh, well, I guess, unless I make this silent, which I don't want to do. Oh, is that diameter instead of radius? Oh, that's probably why. Yeah, that would do it. Okay, there's your problem. Okay, so now if we do standard hats, yeah, so you can do your standard hats like that. And our hole is very big, but yeah, you can do your holes. Okay, and I probably need to fix that error handling a little bit. So if your circles are clipping together, or I think that's what happens when one circle is completely larger than the other, and then it goes poo-poo, which is a little obnoxious to be sure. But yeah. Okay. Locations, I guess. Oh, okay, so I'm just gonna write a wrapper for this that does the same thing, but computes the centroid. Right. So that way centroid is optional, and then I can even document that if I want to be fancy. Vector optional. Right. Okay. And then, yeah. Okay. And then the functions I updated is counterclockwise. Yeah, so these are good again then, which is good. And then this is fine. That's fine. And then this call here doesn't need that. That call there never had it. And this call here, I think did need it. Because it's used down there. Yeah, it's returned. Okay, cool. Cool. So, yeah. All right, excellent. We are very happy with that. So next time, should be able to put the finishing touches on this feature. Add those extra holes, and clean things up. Is performance decent? Yeah, performance is actually not too bad, especially for a simple plate like this. 37 milliseconds is very reasonable. It's actually about on par with like a whole feature, honestly. I think. Yeah, a little bit. Okay, maybe a little cheaper than that, but yeah. Yeah, you cut a couple holes and performance comes up pretty fast, actually. So, yeah, not too bad. Alright, so I'm going to leave it off there and go to bed, because it is late and I am tired, in case that wasn't obvious. But yeah, making good progress. Reasonably happy with this. And yeah, keep playing with it. But yeah, almost finished. So that's all I have. Hopefully that was helpful. And it, you're not totally lost. Sorry about that. But yeah. So next time, a little bit of code cleanup and finishing touches. All right. Talk to you guys later.